Okay, so the function g has derivatives of all orders for all real numbers. The Maclaurin series for g is given by g of x. So g of x, it's the Maclaurin series for the given function on its interval of convergence. Part A state the conditions is necessary to use the integral test to determine convergence of the series, and use the integral test to show that the series converges, right? So we have this function or this series of part A. So f of x is equal to 1 over e to the power of what? E to the power of, I'm replacing n with x, right? Which is e to the power of minus x. So there are three conditions to use the integral test. What are they?
Continuous, positive or decreasing?
Continuous, positive, and decreasing. So this function is continuous on what interval? From 0 to infinity. How did we know? Look at that sigma from n equals 0 to infinity. So this is the first condition, continuous, and then this function is positive on its domain and decreasing. Decreasing. Now we need to apply the integral test. So the integral test, we will go from
0 to infinity.
0 to infinity of e to the power of minus x, right? dx. But this is an improper integral, so we will replace infinity with b or t or whatever. So I would like to use t as t approaches what? Infinity, and we will go from 0 to t
E to the power of minus x.
e to the power of minus x
dx.
So far so good? Okay, so we will do the integral and the limit will do it at the end. So the limit as t approaches infinity. What's the integral of e raised to minus x? Minus e raised to minus x. We evaluated it from
0 to t.
From x equals 0 to
X equals t.
x equals t. Now we will plug in the upper minus lower, and we still have the limit in front, right? As t approaches infinity. So this is going to be minus e to the power of
Minus t.
minus t minus e to the power of 0. And this is going to be 1. E to the power of minus infinity. How much? E to the power of minus infinity?
0.
0. Excellent. It's 0. 0 plus e to the power of 0 will be 1. So the integral, what do we say? The integral converges, so
the series will
so does the series, right? Which series? This one. So it converges by the integral test. It converges by the integral test. Understood?
Yes.
Use the limit comparison test with the series to show that the series g of 1 converges absolutely. So we will use which test? The limit comparison test. Space. Use the limit comparison test with the series sigma of 1 over e raised to n to show that the series G of 1 converges absolutely. عليكم السلام. So what does the limit comparison test say?
That if one converges, the other will converge.
We will find the limit of their ratio, which should have two series, right? We'll find the limit of an over bn. If the answer is positive and finite, we say both converge or both diverge. So the limit as n approaches infinity. Oh, okay. Now we have two series given in part B. Which one is an and which one is bn?
AN has to be the less value. Or the main one.
When we studied this lesson, we said the new one, the original one over the one we created, right? But in this question, I think both are accepted because
we can compare both.
yes, you have to find the ratio of the first one over the second one, or the second one over the first one. So let's go for 1 over e to the power of what? N. All over what? 1 over
2e to the power of n plus 3.
2e to the power of
And n plus 3.
n
Plus 3.
plus 3. Okay? So I just ignored the negative 1 raised to n. I was looking at the limit as n approaches what? Infinity. So this is the limit as n approaches infinity, 1 over e to the power of n times
2e.
2 e to the power of n
Plus 3
plus 3, which is equal to 2, right? Now,
we don't have e to the power of n because it's times 2.
which one?
Here?
So you have to look at the strongest terms here. What's the strongest term here? It's the exponential, right? And here, the exponential. So this limit equals to what? It's equal to 2, right? 2e to the power of n plus 3. And because the 2 is positive and what? Finite, that means
We can use
both converge or both diverge. So we have, in part B, we have this one and this one. But this one from part A, what? Converges. And because the first one converges, the second one
would also converge.
will also converge. So it converges as well. Right? Who's having the answer key? The answer key of this question?
And the other two.
Okay.
Question 5, Professor.
Question 5, part B.
Part B will answer.
It can be 2 or it can be.
Absolutely.
It can be 2 and it can be what? 1 over 2 because here the reciprocal of the given ratio is an acceptable alternative. So the limit in this case will be what? 1 over 2. So if we flip them, it's also accepted. Okay? So this part B has how many points? 2 points only? Okay. So we have to go back and say it converges absolutely, not only converges, in order to get the full credit.
Because 1 over e to the power of n converges absolutely.
1 over e. So here we just say converges absolutely. And you have to state that this is g of 1 maybe. So G of 1, which is equal to what?
The summation.
The summation n equals 0 to
Infinity.
infinity negative 1 raised to
N.
n over
2e to the power of n
plus 3 it
converges absolutely.
converges as we say find the yeah converges absolutely.
They also
Show that it converges absolutely.
And you get 1 point from the question itself.
It's going to converge. You just need to show that. Okay.
Cancel the 3 and then
Here.
yes.
Yeah, but because I asked what is the strongest term here, E or 3? The E. So this plus 3 has no effect. It's infinity over infinity, but we have E 2 here, so we can cross this one out, okay? Because it's nothing compared to E, right? Determine the radius of convergence. So when you read radius or interval, both of them require which test? The ratio test. We need to find the radius of convergence of the Maclaurin series of G. Where is the Maclaurin series of G? The original one, this one. So we have to apply what? The ratio test. Okay. So for part C, the given one is
X to the power of n
x to the power of n
over 2e to the power of n
2e to the power of n
plus 3.
plus 3. N goes from
0 to infinity.
0 to infinity. This is an, right? This is an. The ratio test requires what? An plus 1. So this is sigma an, okay? We need to write a new one, an plus 1, right?
Yes.
So this is n starts from 0 to infinity.
X to the power of n plus 1
Over
2e n plus 1
n plus 1
plus 3.
plus 3. What we have written is
n plus 1.
an plus 1. So the limit as n approaches what? Infinity of something multiplied by something, okay? So the other part will be the reciprocal of the original one, and the first part will be an plus 1. But let's break it down. And instead of writing x to the power of n plus 1, we can write x to the power of n times x to the power of n.
مستوى الابسولوت مو بعلى بالانتباه؟ الابسولوت مو برا عفوا؟ ولا ما يفرق؟
Keep it inside better. Okay? Yeah. Over
2e to the power of n
2e to the power of n. Okay?
Can you say the time?
Times
2e to the power of
e to the power of what? 1. But there is plus
3.
3, right? And here
2e to the power of n plus 3
plus 3
x to the power of n
x to the power of n. Clear? X to the power of n well?
X to the power
X to the power of n.
2e to the power of n.
No, we don't cancel them. Because this is one thing and this is one thing as well. Okay? Be careful. So what do we do now? We will write what? The limit as n approaches infinity
x
of. Okay. The remaining here on top is what? X. Here
2e to the power of n plus 3
2e to the power of n plus 3
over
over
2e to the power of n times
e to the power of 1 e times 2 2e, right? E to the power of n plus plus 3. Okay? So what's the answer of this limit?
2 over 3. I mean x over.
We have an absolute value, right? X remains, right? Now, the highest function or the highest term here is what? The
e to the power.
e to the power, and here e to the power. So we need to look at the ratio of
2 over 2.
the coefficient, right? So 2 over 2e, and this is going to be what? We can cancel the 2 with 2. That leaves us with
X over e.
x over e with
Absolute.
absolute value. Now, in order for this given series to converge, it has to be less than
1.
1, right? It has to be less than 1. So this x over e absolute value is less than 1. We can write it as x over e is between 1 and minus 1. We will multiply everything by what?
E.
Multiply it all by e. So this is going to be
Minus e.
minus e,
X.
x, and e. This is called what?
The interval.
The interval of
Converge.
convergence. The radius of convergence will be
X.
half of this interval, right? Half of this interval. Now, if you look back at the series, yes, what's the center of this series? What's the center of this power series? 0, right? So the interval goes from
Minus e.
minus e to e, and the center is at 0. So half of this interval will be what? The radius. So the radius r equals what? E. This is the radius of convergence. Okay? Let's look at the points distribution. Yes? The center, if you look at the series at the top here, okay? Here. Do you have x minus something raised to n?
No.
Yes, there is x minus 1, x minus 0. So what we call the 0? The center. Okay? Maclaurin series, right?
آخر part.
Okay, before we do the last part, let's look at the marks distribution of part C, if there is anything we need to pay a close attention to.
Can become 1 point.
3 points. So R equals 0. The radius, the third point cannot be earned by presented an interval. You have to, even if you are finding the interval, you must say that R equals E. Otherwise, you will get 2 out of. So you have to set up the ratio, which is the ratio test. The limit, which is 1 over E with times x, or x over E, and the radius. So there is nothing. No, here, R equals E. Here, R equals E. Okay? How many points? It's 1 point for the last part. Part D. Okay, so let's look at part D. The first 2 terms of the series G of 1, okay, are used to approximate G of 1. Use the alternating series error bound to determine an upper bound on the error of the approximation. So how many terms we are finding here? We are adding 2 terms, and this series is an alternating series and it converges, right? This series here, it converges. It's here. If the series converges and it's an alternating series, then we can use the alternating series error bound formula. So the maximum error bound is given by what? The error, this is part D. The error with absolute value, right, is at most what?
AN plus 1.
N plus 1, right?
Which is A3 in this case.
Which is in this case, what is which term?
A3.
The third term, because the question said we use two terms. So this is going to be what? A3. This is the third, right? So what is the third term? What is the third term of G? What is the third term of G? So the first term is by substituting n equals what? 0. And the second term we are
1.
substituting 1. The third term will be n equals what? 2. So you will plug n.
1 over.
So the error is going to be what?
1
We
over.
will plug in n equals 2. So?
Yes. So x to the
X to the power of what? No, not x.
Not
X is 1.
1
right?
over 2e to the power of 2.
So we are using which sigma? This one or this one? It will be the same because x equals what?
1.
X equals 1. So it will be negative. Will a positive? There is no negative, stop. Because there is an absolute value. So 1 over
2e to the power of 2.
2e to the power of 2 plus 3. Notice that we substituted what, Yamana? We substituted n equals 2 because the first term will be 0. The second term, this is A1, the first term, this is A2, the second term, and this is A3. This is the first unused term. So the error is given by this formula. At most 1 over 2e to the power of 2 plus
That's it, yeah.
3.
For this part.
Let's see what they are saying. Where is part D? 1 over 2e to the power of 2 plus 3. Only for the answer there is 1 point. The terms of the alternating series decreases in magnitude to 0, يعني the series converges. And we can apply the alternating series formula, which is given by the first unused term, which is the third term. You don't need to write all of this, we just need to apply the formula. The answer. The error is at most A3. Most of the AP questions are out of 9 points. So, and in the final exam, the total number of points will be 40. So they might, for some questions, they might eliminate option D or C. Yes, they did it before, just to make the 40 points fit the 5 questions and to make it shorter.
عشان الوقت بعد.
Exactly.